In this lecture, we are going to create a table in our database. We're not going to work with the tables by WordPress. Otherwise, we may run into problems. I always recommend creating a table purely for experimenting with queries. Unless you know what you're doing, you can mitigate a disaster by working with a dummy table or database. It's very difficult to fix databases. For this reason, I recommend regular backups. Let's try creating a table in our database. On the right side of the page, there's a link called SQL command. We can click on this link to navigate to a page for writing a custom SQL command. We are given a simple text box for writing commands. Let's try creating a table. Inside the box, type the following command: create table. First and foremost, like any other language, SQL languages have reserved keywords. We can type these keywords to send instructions to the database. In this example, we are using the create table keywords. As the keyword suggests, we can use them to create a table in our database. The syntax for databases is very different from the syntax for programming languages. For example, I've written these keywords with uppercase letters. However, SQL is not a case-sensitive language. We can use a mixture of casing, or we can write these keywords with lowercase letters. It's common practice to use uppercase letters for all reserved keywords in the language. This helps developers identify SQL keywords from their own values. For the remainder of this course, we are going to follow this convention. Next, we must provide a name for our table. Let's set the name to products. This table is going to store an imaginary list of products. After defining the table's name, let's add a pair of parentheses. Inside these parentheses, we can start adding a list of columns for the table. This portion of the query is where we can describe the type of data that can be inserted into the table. The format for adding a column is simple. It's the name of the column followed by the data type. Let's add a column called ID. ID columns are the most common types of columns that can be added to a database. To prove it, let's open the Posts table in another tab. Do not navigate away from this page. Otherwise, you may lose the original query. I'm viewing the structure of the table. The structure of a table is called a schema. If you're not able to view this page, you may need to click on the Show Structure link at the top. The schema will describe the columns added to the table. At the top of the list, there's a column called ID. In a table, thousands of rows of data can be added. It's not unheard of to have millions of rows. Data can be updated after being inserted into a table. While it's great that data is flexible, it becomes difficult to track data. Most database developers agree that adding a column called ID is the best way to keep track of a row of data. If you were to look at the structure of the other tables, you're going to come across an ID column. It's a standard practice in most databases. Back to our query, we will add a column called ID. This column's value should never change after a value has been inserted. Next, we must provide the data type. In the resource section of this lecture, I provide a link to a list of data types. Unlike programming languages, databases will have dozens of data types for the same type of value. Let's look at an example by scrolling to the Numeric Data Types section. There are several data types for storing numbers. Why have so many data types? Databases are heavily focused on being efficient. Every second counts. A program cannot continue executing an action until the database responds with data. Any database worth its salt will allow developers to fine-tune the type of data that can be stored in a table. Let's say you're trying to store test scores. A test score can range from 0 to 100. You may not need to store a value higher than 100. If that's the case, databases shouldn't have to worry about storing higher values. Unlike programming languages, databases can have a set size for a column. For example, we can tell the database that we plan on storing numbers with 3 digits. By doing so, the database does not need to strain itself with higher values. Databases introduce data types for different sizes of the same value. For example, the tinyInt data type can store numbers from -128 to 127. What if we need to store a larger number? There's a data type called int for storing numbers in the billions. Need something bigger? The BigInt data type has you covered. Feel free to check out the other data types. Let's head back to the Adminer tool. Let's add the BigInt data type. WordPress recommends this data type for IDs. You can look through the structure of other tables for their data types. Next, we must provide a size by adding a pair of parentheses. Inside these parentheses, we can specify a size, which is the maximum number of digits that can appear in an ID. Let's set the size to 20. The ID should always have a value. We can add the not null keywords after the data type to prevent empty values from appearing in this column. By default, if a value is not provided for a column, the value will be set to null. MariaDB is capable of performing basic data validation. If the data type is not a number or is not provided, the action will be rejected. Let's add another column by adding a comma. The name of the next column will be called name. Before moving forward with the column, let's talk about the formatting. SQL does not care about the formatting. We can write a query on a single line. For readability, I recommend formatting your query on multiple lines. We're indenting the column names. Not required, but recommended. Back to our column, let's add the data type to varchar with a size of 255. Strings have various data types. You can refer to the documentation page I linked to earlier for a complete breakdown. The varchar data type will allow a column to store a string with a specific size. We can configure the data type's size inside the parentheses. In this case, we're going to allow a maximum of 255 characters. We're finished. Before executing the query, let's add a semicolon at the end of the statement. The semicolon character indicates the end of a query. A new query can be written after the first query. After adding the semicolon, let's execute the query. After a second, the table has been successfully created. To the right, the products table has been added to the list. Let's click on it. As you can see, the table's structure is similar to the query. The ID's data type is BigInt with a size of 20, whereas the name column has a data type of varchar. After creating a table, we can begin inserting data. Let's start adding data to our table in the next lecture.